So everybody should be able to see my screen now. Welcome to my talk, Pimp your Jakarta EE applications. And I kind of jumped in this morning for a other presenter that wasn't able to attend. And I hopefully have set up my environment properly. We'll see. Well, just a few words about me. I'm Dirk. I'm the CEO of Gedoplan. We're in Bielefeld and doing Java Enterprise, so Java EE, J2EE, Jakarta EE, Spring Boot since the end of the last century. And I was on JCON in Cologne this year. Maybe you have seen me there on some user groups this year. And there's some books that I've published. Well, that should be enough about me. And let's dive into our main theme. The talk is called Pimp your Java EE, Jakarta EE applications, and the focus on customers or people, maybe a part of you that have working Java EE, J2EE, Jakarta EE knowledge, have applications that run on application servers, maybe with Java EE8 or Jakarta EE8 on a WildFly, for instance. WildFly 26 was the last WildFly for Jakarta EE8. And now you want to keep up with the current evolution of the platform and do something more modern. And well, what do you have to do then? And to make it visible for us, I've prepared a small demo application that's not just a Hello World. It's a full stack. It's a REST API, some small business logic in the injection container in CDI. And we have a database under it, a Postgres database, and connect it or use it via JPA and Hibernate. So that's a small application. It's made small so all of us can understand it in a minute. But it's a full stack, so it's like any other application that you might have. Let's just walk through the application for a few minutes. So in my IDE, the project is on GitHub. So in the end, you can check it out and play around with it if you want. So how is the project set up? It's a Maven project, so we have a Maven POM file here. And for Java EE or Jakarta EE, you normally need just one dependency. I've used the Java EE dependency here. There's a similar one for Jakarta EE, but for version 8, there's no difference between it. So that's the main dependency. And well, we have a entity class here. That's a JPA entity class annotated with @entity, and that's from the package javax.persistence. That will be one of our focuses later on. And there's nothing really special with this class here. It has a generated ID and some attributes, constructor. And well, we're doing something with Lombok here, so getters are created in the background, but that's not the focus here. So it's a standard JPA entity class. And we have a repository that gathers all the access methods for the database. It's kept simple here, so it's just inserting a person into the database via the entity manager persist method and finding something by find by ID and so on, or find all listing all the persons in the database. Nothing very special here, and yeah, and we use the entity manager by injection. That's one of the normal procedures that we have when developing enterprise applications. The entity manager is injected here and is used in the remaining methods. And then we have a REST API resource class here with some endpoints. And again, the repository that we saw is just injected here and used in the endpoint methods. And in order to make it not just a CRUD API, there is a service as well that will compute the average age of all persons in the database, and that as well is used in the endpoint, in one of the endpoints. So that's a simple, small but complete application, and we will use that as a starting point. Okay. So if we want to move on to Jakarta EE 10, there are some obstacles in the way. One of those obstacles is that we have to rename our package names. As you will know, when Oracle donated the Java EE platform to the Eclipse project, Jakarta EE, the package names were allowed to use, but not there's no change possible in there. So all the package names that belong to the EE platform had to be renamed. So the old package names javax.persistence, for instance, have to be renamed into jakarta.persistence. And that holds true for all the EE packages. And unfortunately, that's not all JavaX packages. There are some JavaX packages that belong to the standard edition and not the enterprise edition. So they stay on the JavaX namespace, and only the EE packages have to be renamed. If you want to know which package names that are, we have a block entry here where they are listed. So these are the package names that you have to change from javax.something to jakarta.something. And that's not the only thing that you have to do. You have to move also some property names in deployment descriptors. For instance, in the persistence XML, that is the deployment descriptor for JPA, there may be some properties like this, and they have a prefix javax.something, and that as well has to be changed into jakarta.something. And also the namespaces, the XML namespaces change, but that's not so important because the old namespaces still work. So there's a lot of renaming that has to be done. And of course, you have to update the dependencies from the version 8 to version 10. Yeah, and you could do that by hand. You could go into your source and change that, do some text replacement. Some of our IDEs are capable to support us. Yeah? For instance, IntelliJ has a migration tool built in that you can use. But I want to focus on a IDE agnostic part. There is a project, an open source project, Open Rewrite, that you can use for source code refactorings. Many more things than just the package name renaming. But package name renaming is among them. And all those changes that are refactorings that you can do with Open Rewrite are specified in so-called recipes. It's, well, kind of a script or description of what has to be changed. And the change takes place on semantic trees. They have so-called lossless semantic trees. So your sources are read into a tree, and that keeps your indentation and comments and so on. And then recipes transform the tree into something new and is written back to your project in the end. I want to show that for the package name renaming and property renaming and so on. And for that, I have a plugin in a Maven profile here to Jakarta. I've named that. And there you see the Rewrite Maven plugin. And I've activated two recipes. The first recipe is for these package name renamings, and the second is for working on this persistent XML deployment descriptor. Yeah, there are many more recipes. You can have a look on the website of Open Rewrite and find them there. But just for a demo, I've included those two here. So we can use that to transform our project to Jakarta EE 10. Well, in the end, it's Jakarta EE 9, yeah, because the package name changes took place there. But Jakarta EE 9 is for me, of no interest, because it has no development in the platform in comparison to Jakarta EE 8. So the interesting part is Jakarta EE 10, because there are new things in there. But the package names were in Jakarta EE 9 as well. So let's run this plugin here. So in a terminal, I would then use Maven in this profile to Jakarta, and the goal is a rewrite run, yeah, and that will read my project into this semantic tree and transform it by these two recipes that are specified in the POM file. And it will also transform or modify my POM file, but I will twiddle it a little bit, and yeah, let's see if after it's finished. So that's not the case. So in the POM file, there are some changes here. Open Rewrite places single dependencies for the parts of Jakarta EE in your POM file, and I would rather use the umbrella dependency here. So I throw those things out here. That's just a personal preference. Yeah? So you can choose either way you want, but I like it small and use these umbrella dependencies. Okay, so that's my new project now on Jakarta EE 10 with the correct namespaces for packages and so on. We can have a look at the differences that have been made by this plugin. For instance, our entity class, the person class, has been changed with regard of the package names. javax.persistence.something is changed in jakarta.persistence.something. Yeah? Or the persistence XML. Yeah? There you have this namespace change for XML namespaces, and you have the change of the configuration variable here. Yeah. Okay, so this application now is has kept up with the development of the platform and could now be deployed onto a application server that runs Jakarta EE 10, for instance, WildFly 27. That was the first WildFly version that was up to date with Jakarta EE 10. Okay, just for timing reasons, I won't start it on the application server now because we want to do something more. First of all, let's have a short look on the transitional runtimes that we have. When J2E was born, and the same holds true for Jakarta EE or Java EE in between, your project produced normally a small deployment artifact, like a WAR file. Or if you have some older projects, maybe it's an ER file. Yeah, but you compile only your application classes or package your application classes therein, and you have configuration files, mainly these deployment descriptors like persistence XML, maybe some additional properties files or whatever your application needs, and you package that into a WAR file that's quite small. If we have a look at our WAR file that our project builds here, that's just, I think, 13K. That's nothing. So in the target, we have this Pimp minus je.war, it's 13K in size. That's nothing. Well, it's a small application, but even if you have a real life application, it's still small in respect or in comparison to the whole application server, which will be 120 megabytes or so. Yeah. So the deployment artifact is quite small, and then you deploy that onto a server, and there is all the rest of the software. There are all the runtimes for CDI, for REST, for JPA. That makes the size. Yeah, and also there's a technical configuration, so configuration of database access, usernames, passwords, and so on. It's in the server's configuration, and then you run that on a Java runtime. And I think originally in the last end of the last century, it was meant to, because servers were big. It was meant to be used in a kind that you have one big server and then run several applications on it. So the server is kind of an operating system for EE applications. But for organizational reasons, we do not normally do that. We have normally rather one application per server than many applications. Because if we run an application for a different customer, we do not want to share the same server with applications of the different customers. Yeah? And servers are virtual today. The application servers are small in comparison to that we have in the late 90s. So we have normally a nearly one-to-one relationship between application and application server. And that makes it feasible to ask if we could potentially build the application into the server or combine it with the server in our project setting. Because if we talk about lightweight or heavyweight, it's not the size of the server, but it's the fact that you have to configure, install a server in your target environment and configure it there, and then you come with your deployment file. And it would be nice to have that configuration, that provisioning of your server in your project, because it's just a one-to-one relationship. And that can be done with, I've called them Jar server runtimes. Yeah. So the proceeding now is we have our application still, application class and configuration files, deployment descriptors, and so on. And then we have the server modules, and only the ones that we need. Yeah, the server is a one-size-fits-all solution, but our small application just needs REST and CDI and JPA, and no messaging, no mail server, no additional things. So we can use a much smaller server for application, and that can be done with those server runtimes. Then you build your application. The normal outcome is a jar file. That could be a fat jar file where the server plus your application is in, or maybe you choose a hollow jar file that's the server in a jar file configured for your application, and the application is separate deployment artifact, and you can start it on the command line in one go. Yeah? So no pre-configured server is just a part of your project. That could be done with several vendors. Yeah? You can use WildFly, OpenLiberty, and so on. They all are capable of doing that. For our demo, I used WildFly, and that's a WildFly Bootable Jar. Yeah? That's a plugin for Maven, and it downloads a server in fractions. Yeah? You have layers and feature packs that are downloaded by like the Maven dependencies, and it builds in the end this hollow jar or the fat jar, so the server plus application. That's your choice. You can configure it in your project. And that's some additional nice feature. WildFly Bootable Jar offers a dev mode where you can run your application and develop at the same time, and changes are reloaded into the application. I will show that. Let's have a look at this possibility. I've done that in my project, and in the POM file in a Maven profile as well. The profile is WildFly. There is the plugin, and we do not have to understand the configuration as a whole. I just point out that we have some layers here. We can understand that the server here should incorporate the JAX layer for REST services, and CDI for injection, and JPA, and we have a Postgres database driver in there, and some additional things, microprofile things that we could use in the end, but I think time is too short to demo that. And then we can also have some command line scripts. If you're familiar with WildFly, you know that you can use the CLI tool to configure the server, set up databases and so on, the data sources and so on, and that is done here. So in the end, if I run this plugin with the package phase, then a provisioned WildFly is created in my target directory, and I can use that to run my application. Yeah. Let's have a look. So if I do that in that case, just a package phase. So now the application server is downloaded. Just the parts that we need. And now the CLI scripts are executed, that is to configure a data source in it. And now we have in the target directory this WildFly Bootable Jar. That's the server. I've opted for the hollow jar thing. So the application is still in this pimp -je.war, and the WildFly -bootable.jar is just the server. And the size here, 1.5 megabytes, is misleading because it uses dependencies in my local Maven repository. So in the end, the size of the server is bigger. It's roughly about 50 or 60 megabytes. Yeah. And I can run that with Java -jar like any other Java application. Yeah, and if I use this hollow jar thing, then I have to specify these minus deployment parameter on the command line. If I had opted for the fat jar option, then just the main jar file would contain my application as well. So now WildFly starts. If you are familiar with WildFly, you see that's the normal log output that WildFly issues, and it deploys my application. And we can use the application now, for instance, with Perl or some other browsing mechanism, and could have a look at our persons. The persons are constructed are still in my database. Yeah, there's a Postgres running in background, and there are 2 persons in there, 2 inhabitants of Entenhausen, like it's called in German. I don't know what the English name for this Disney world of Donald Duck and Dagobert Duck and so on is. And one of the difficult parts was to find out the birth dates of Donald Duck, for instance. And I'm quite happy it's the same day as mine, but not the same year, obviously. Okay, so the application works. It's in the background, and well, it's running on a WildFly 27 provisioned by this bootable jar thing. Yeah. One additional thing that is quite interesting is that I stop the server here. That you have these dev mode there. So if I start the application by Maven with WildFly -jar def minus watch, then the application, well, the server is provisioned again, and the application is run in a def mode then, which will keep up with your changes that you do in your project. So for instance, we have a simple resource here for demonstration. It's a endpoint that just returns hello Jakarta EE with a exclamation mark after it. And if I change that, if I request that, obviously, we will have the hello Jakarta EE there, and switch to the other shell here. If I do some changes here and save them, then you see that the WildFly application server in def mode reloads these changes immediately. Yeah, so you can develop your application, and you do not have to explicitly redeploy your application to try it out. It's just done in the background. It's quite convenient. Yeah. It's a polling, so the application watches your sources and recompiles them if they are changed, regardless on some other actions that you do. Yeah. Okay, so that's so now we have the current version of our application. It's quite quick. If you're too quick, yeah, then you might end up in a not found because the application is shut down and then reloaded. But after a short while, very short while, you have the current version of your application running in the background. So that's quite nice. Let's stop that and move on. If that is still not what you want, because you still have an application server and you have some starting time there, and if you want to have a little bit more modern, like Spring Boot, I think, yeah, I would say, so the application contains the server part, and you do not have a separate server, then you end up with I've called it micro runtime framework, because there are several. Some colleagues or people think Spring Boot is the only option here, but that's not the case. Yeah. The way you go now is you have your application classes still and configuration files, and then you package it with the runtime parts of that what you need on the server side. Yeah, so we package it with the runtime for REST and CDI and JPA and so on, and build a jar file that is run on the Java runtime directly. And again, that could be a fat jar where the application, including all its dependencies, are built in, Über Jar, for instance. Or what is more convenient, especially if you focus on containerized applications, your application and the dependencies in some special library directories. Yeah, so you can package that easily in a Docker image also. Yeah, so what you have to keep in mind is that now the configuration includes the technical configuration. So database connection parameters are now part of the application. Yeah, because we have no separate server it's just the application. So different credentials for the database, for test and prod, have to be configured in some way in your application now. Okay, what could we use for that? If we want to stay with Jakarta EE, then Spring Boot is not the option, because Spring Boot has is a similar framework, but it uses other classes, other packages, and so on. So you would have to migrate your application to Spring Boot. If you want to stay with Jakarta EE, then Quarkus is an option. It's not the first option, by the way. With regard of time, there have been frameworks for doing that a long time, many years, like Cumulus EE, for instance, but they have not gained the same market share. Yeah? Quarkus is different. Quarkus is, well, still hyped, It came out 2018, I think, it comes from the same vendor than WildFly, and it's optimized for memory usage and time to first response. We'll see that in a minute. And that is partly done by optimization at build time. So there are things done at build time that other frameworks can do at runtime first by reflection, like matching injection points to injected beans. That's a part of setup or initialization of a injection container at runtime. And this matching in the end is static. Yeah, so you know the beans that have to be injected in some injection points already at build time, and Quarkus makes use of that. Yeah, so at build time there is some glue code produced that can be run in the production later on in runtime immediately without doing reflection for those things as we have done before. Yeah, there's a quite nice website, quarkus.io, where you can also see the huge ecosystem that Quarkus already have. If time is enough, we can have a look later on. So what would you have to do to make your application run in or with Quarkus instead of WildFly? Well, it's small changes, and that is quite interesting. Yeah, so first of all, again, we have to specify something in our POM file, and it's quite similar in a way to the specification of the layers of our WildFly Bootable Jar before. Yeah? Now we have dependencies here for, well, Quarkus names that extensions. We have an extensions for REST Easy, that's the REST part. We have Arc, that's the application runtime container, that's the CDI part. And we have Hibernate in there and Postgres and so on. So that resembles in a bit the layers of the WildFly Bootable Jar that we had before. And we have a plugin as well that is doing the packaging part in the end. So it produces a startable run file, a jar file. Yeah. So if we do that, we have that in a Maven profile as well. If I package or build my application with Quarkus, that would be a Maven package as well in this Quarkus. Package is a default goal, and that will build a directory in the target directory, Quarkus-app, which holds the application. And we can have a look at that in Quarkus app. So that's the application. This is starters, more starters, just a wrapper around class path dependencies. And application is in a subdirectory. The dependencies are in a subdirectory. And this Quarkus directory, there is this so-called what I call glue code. So the code that is built at build time for these things that normally or in a traditional environment is done at runtime by reflection. Yeah? And the whole application is quite, well, it's smaller than we had that in the application server environment. So this whole Quarkus app directory contains 36 megabytes. If you compare that to a traditional, maybe Spring Boot application, or use this Cumulus EE or even the WildFly Bootable Jar, that's way smaller. That's because at build time, this plugin can determine that some of your application parts are not used. That you can throw that out. The phase is named augmentation, so it enhances your application, but there are also things that have been thrown out because they cannot be used. They are not reachable in the application. Yeah. So the application is startable as Java application, as we did that with WildFly, but now we start this Quarkus run thing, and that starts here in my environment now in roughly 3 seconds. That is quicker than we normally have with an application server or even a Spring Boot application. Yeah. And of course, it has the same contents now. So we have this persons in there, 2 inhabitants of Entenhausen, and also the greeting endpoint that we had is still working there. But we'll show that later on, because Quarkus has another cool feature. If I stop that here and start that with Quarkus minus colon def, then we start a def mode here as well. It resembles a little bit the def mode of WildFly Bootable Jar, but here the def mode is, or the reloading is triggered by external requests. Yeah? So if I change my greeting resource here and add there something in the store that, and then they see nothing is happening on the shell, so no hot reloading still. But if I request this endpoint, the greeting endpoint, now the hot reloading takes place in the background. Yeah. So the hot reloading is triggered by the external request, and there's no chance of hitting the application in between, like I did that with WildFly before. Yeah. So you have to wait a little bit. Reloading is done quite quickly. It took 1.5 seconds here. And you can configure that in a properties file. And there should be, oh no, I didn't do that here, sorry. You could configure that for doing the reloading, or instead of reloading the whole application, you can use instrumentation so that only the changed classes could be replaced by the new ones. I forgot to configure that here. So this reloading time could be even less, under a second, if we use instrumentation for that. This def mode is quite interesting in various ways. Yeah? One thing is shown here. I forgot to mention that in Quarkus, as in Spring Boot, for instance, we will now configure our application in a central properties file, application.properties. You could use YAML as well if you want. And I will take your focus to that prefix here. We have a prefix for some, obviously there are database connection properties, like a connect URL and username and password. And they're prefixed with %prod. And that means these properties are active only in prod mode. Prod mode is the one that is started when you start the application with Java minus jar. If we start the application in def mode, then the configuration profile used here is def, not prod. So in the end, we have no database connection properties for def mode, but the application is working. Yeah? If I use curl, for instance, to go to our persons endpoint, then there are persons in there. So where do they come from if the application has no database configuration? Yeah? And that's part of the magic that Quarkus keeps in it. These extensions, for instance, for databases like Postgres, they start a test container. They're called dev services here. if you have the extension in your application, but you do not configure it, then you have an auto configuration that starts a container. So the database that I'm using now is a temporary Postgres container, separate from my normal environment. It's just for the application. Those dev services exist for databases, for identity managers like Keycloak, for message brokers like Kafka. Yeah, so it makes the entrance fee that you have if you want to start a new application quite low. Yeah, you can just start developing your application. You tell it you want to have Postgres in it, and it will start up a Postgres database for you. Yeah, so it's very, very easy. If you go further in your project, you maybe at some time will choose to have a development database instead of this test container. That's perfectly fine. You can define the data source properties for dev mode as well. Yeah, and then no container is started. That's very, very convenient. And another thing that I would like to share with you is, I don't have that in this presentation here, but I will do a presentation for Quarkus in comparison to Spring Boot in the afternoon at 2 o'clock. And there I will also focus on testing, yeah, because that's another cool feature in WildFly, but in Quarkus. So, okay. Let's just stop for a second here. What did I do to migrate my application to this modern, nice environment or framework? With regards to my application classes, nothing. Yeah. Every source that I had is still working. Yeah. It's a little bit of a lie because the producer for Entity Manager and the persistence XML deployment descriptor are not used anymore, so the project could be smaller. With these properties here, I ignore them. In a normal project, you wouldn't have them in the first place. But all the other parts, like my person entity, the REST endpoints, and so they are unchanged. So I can keep my invest in existing software. I can keep my invest in my knowledge. That's maybe even more important. So I can keep that and use a more modern, more smaller environment, an agile development environment, but without having to migrate all our classes there. Yeah, that's very, very important in my opinion. So there are some more cool features. Time is too short to show them all. Dev mode with hot reloading, I showed that. Dev services, I mentioned that. Continuous testing, I will do that in the afternoon. We have a native mode. We could compile the application into a native executable, and then it won't start in 2 seconds, but in 50 milliseconds. Yeah, that is meant for serverless applications or so. Yeah, because obviously it has no potential for optimizing it when running. Yeah, that is done by Java applications with the hotspot engine, quite good. So a native application cannot do that. So native applications are meant for short-running applications. Yeah, serverless, quickly scaling to 0, and so that's native. Yeah, and we have a huge ecosystem. If you want to have a look at Quarkus.io, there are many, many extensions that you can use. Yeah. So here, that's the ecosystem that we have. Yeah, and it's constantly growing. If you want to include third-party projects like Camel, like Kafka, messaging broker in your application, there is an extension for that. Yeah, and it's constantly growing. And even if you say in Spring Boot, we have these nice repository magic that constructs repository methods from an interface, even that is an extension that is available for Quarkus. Yeah. Okay. Time is too short to show that, but if you want to use microprofile to configure your application, that is included in Quarkus as well. But I could show that just quickly in our greeting resource. That would be the code that you would use to inject a externally configurable property. So the greeting that the header endpoint returns to the caller can now be configured by either a default value that is in the application properties or by a environment variable that is specified in the runtime or system property and so on. So that makes our application some kind of cloud ready, because in the cloud configuration is done mainly with environment variables. That is the case here now. That's very simple, and that's built in into Quarkus as well. And it's the same code for WildFly. So that is portable as well. Okay, but for all the rest, the time is too short here. But we could again extend our application for health checking, which could be consumed by pods in Kubernetes, for instance. We could use metrics like CPU utilization, memory utilization, or even runtime values that we produce from our business logic can be published to, for instance, Prometheus. So that's all in microprofile, and Quarkus contains that as well. Okay, so that's what I could do in 3/4 of an hour. The project is on GitHub. You can check it out and play around with it. And the slides, you can find them on SpeakerDeck, speakerdeck.com/Dirk Weil. There are the slides, you can download them from there. Okay, that's what I could do for you. Are there any questions?
All right, thank you for your valuable inputs. Also, thank you for stepping in for the other speaker. I've already seen a question in the chat. Maybe we can start with that one.
Yeah. So,
if you stop sharing your screen, you can also check the chat yourself, but I can also read the question out loud.
I have the chat here. Which part of the presented stack is open source? Everything. Nothing from what I've shown is in some way closed source. Everything is all open source. There's no tooling helping with renaming. Yes, there are tools. Open Rewrite is one of them. There are others, and Quarkus, for instance, uses Open Rewrite as well for their upgrading tooling. You can upgrade from Quarkus 2, which is JavaX namespace, to Quarkus 3, this is Jakarta namespace, and they use the Open Rewrite tool as well for that. But there are other tools. There are tools in your IDEs. I know that IntelliJ has something in it, but I think Eclipse doesn't. So it depends on what your IDE is, and Open Rewrite is always an option for you. Then Quarkus is too often seen as a way to have native app builds from. That's right. Native builds, as I said before, just for it's edge cases, like serverless applications where you want to start up your application in no time, do something small, and then scale to 0 again. Then you cannot utilize the normal optimization that the Java runtime has. The Java server application has to run for a few minutes to optimize itself. So in that case, is a native application is good for you. In all other cases where you have traditional server applications that run for months, yeah, then you can stay safely with normal Java virtual machines. And Quarkus is a framework for doing that as well. It's not only native, it's everything. Yeah, and I had a small application. It's another question that arises often. I had a small application. It's kind of a microservice. Quarkus is not only for microservices. We have several applications we're producing for our customers that are kind of monoliths, yeah, traditionally, and we migrate them to Quarkus and use these dev modes and so on with Quarkus, even if it's not a traditional microservice. Yeah. Okay.
All right. Are there any other questions?
Okay. If there are no more questions, then thank you very much that you attended my talk, and have a nice rest of the conference. And maybe if you have time, 2 o'clock in the afternoon, I will compare Quarkus and Spring Boot. See you then.